Hey guys, I'm going to read aloud your vocabulary for Chapter 5, Periodic Table. So, in the slides that you saw in your classroom with your teacher, it has the English and Spanish audio, it has the vocabulary and visuals for terminology that you'll see throughout the chapter. Now, if the audio isn't working in the slides, then I already attached it to the document in the Google Classroom, in your science classroom. All right, so here we go. So this is just showing you where the audio is. So you have your English and Spanish here for section 1, 2, and 3, which is also attached to the vocabulary, as I said, in the Google Classroom. So now we're just going to go into vocabulary. I'm not going to be explaining it because I don't have a background in this area for stuff. Oopsies. So I am just going to read through it so that you can hear it, okay? So, periodic law, the law that states that the repeating chemical and physical properties of elements change periodically with the atomic numbers of the elements. When the elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. And you can find this on page 147 in your book. Now here, I put the periodic table. I highlighted this in blue, the period, so that you see exactly where it is in this bracket where you can find it, okay? So in chemistry, a horizontal row of elements in the periodic table, okay? And you can find that on page 150. Now a group, green, and then I put it where you can see it with arrows all over so you know exactly where to find it. A vertical column of elements in the periodic table. Elements in the group share chemical properties. This is found on page 150. Now here, ion, an atom, radical, or molecule that has gained or lost one or more electrons and has a negative or positive charge, found on page 153. Now this will be found on page 154. I put 3 of your vocabularies on one slide. So metal, non-metal, semiconductor. Metal, an element that is shiny and that conducts heat and electricity well. Non-metal, an element that conducts heat and electricity poorly and that does not form positive ions in an electrolytic solution. So ions in an electrolytic solution. Semiconductor, an element or compound that conducts electric current better than an insulator does, but not as well as a conductor does. So here is how you can find them on the periodic table, and I try to color coordinate them as well so that you'll know exactly where to look for them. Now, this is another example using those same 3 vocabulary words, but the metals, non-metals, semiconductors. So now you have visuals as to what they're talking about. And this is on page 155. Here, we have that alkali metal, one of the elements of group 1 of the periodic table. So alkali metals are located on the left edge of the periodic table. So this is your left edge. So they have a color-coded left edge right here. Page 157. Then alkali earth metal. This is found in group 2. This is the second row. So the first one was the pink one. Now is the second one. One of the elements of group 2 of the periodic table, the alkali earth metal, is located second from the left edge. This is found on page 158. Then we have your transition metal, one of the metals that can use the inner shell before the outer shell to bond. Page 159. This is where you can find it on the periodic table. Then we have noble gas, one of the elements of a group 18, of the periodic table. So noble gases are unreactive. Then you can find that in group 18, last column all the way to the right. This is found on page 161. Halogen, one of the elements of group 17 of the periodic table. Halogens combine with most metals to form salts. This can be found group 17 all the way to the right, but it is the second column to the right. This is found on page 162. Now, here are some visuals for terminology that you'll hear and see throughout your readings for section 1, 2, and 3 in chapter 5. So I put a picture of the periodic table. So the periodic table of the elements. These are on pages 148 and 149. The periodic table organizes the different types of atoms or chemical elements. The elements are arranged by atomic number in rows and columns from left to right and top to bottom. Vertical columns are called groups. So remember, here's your groups or families of elements, while periods, which is right here, consist of horizontal rows. Now, this is Dmitry Mendeleev. He's a Russian chemist. This is found on page 145. Was one of the first scientists to design a way of organizing the elements. He studied the properties of the elements and looked for patterns among the properties. He found that if the elements were listed by increasing atomic mass, certain properties appeared at certain intervals with the list. Here's another example of the key that you find on the periodic table. So I'm going to just go back 2 slides. 1, 2. This is right here. It's just a bigger visual of it. So now I'm going to go forward twice. So this is another example of the key on the periodic table. And it gives you all the information here: atomic number, chemical symbol, element name, average atomic mass. Here we have the atomic number. So the atomic number is the number of protons in the nucleus of the atom. The atomic number is the same for all atoms of an element. Mass number. The mass number is the sum of the numbers of protons and neutrons in the nucleus of an atom. Because electrons have very little mass, the mass number is very close to the average atomic mass of the element. And this will be the last one. Also on your slides, you could click this and you'll be able to watch a little quick video of it. Orbitals, so 3-dimensional region around the nucleus that indicates the probable location of an electron. So this is it, and then there's the video of it. Now, that was the end of the slides. So hopefully this helps you. If you need any help, remember to reach out to me or to your teachers, okay? I will talk to you soon.
An orbital is a 3-dimensional region around the nucleus that indicates the probable location of an electron.
That's right. Since electrons fill orbitals of lower energy first, the 4s orbital must have lower energy than the 3d orbitals.
Okay, so I played the video by accident. All right, so I'm going to head off now. Talk to you guys soon. Bye.